I am at peace, cocooned in warmth and a reliable thump that lullabies my perpetual sleep state. I hear sharp, urgent noises begin to echo from somewhere outside of my sacred habitat. All in one moment, an unyielding force grips my wrist and pulls me from my home. The force is unrelenting, as an intense pain emanates from my neck, spreading like wildfire down my arm and spine. Right as my eyes widen to the blinding brightness of a new environment and chaotic moving shapes, the force stops, but the pain does not. The shapes carry me, pass me to one another, bark loud sounds. My senses are overwhelmed, and I am helpless. The moment I was born was the same moment I experienced the worst pain in my life. The doctor had ordered a vaginal delivery for me, a 10-pound, 5-ounce newborn. My mother's pushing during delivery was not enough, so he grabbed my wrist and tugged. The nurses ushered me away as my hand and arm curled into themselves, knowing very well that my injury was severe. The doctor, after all, had delivered several other newborns this way before. When he placed me into my exhausted mother's arms for the first time, he soothed the desperate, worried gaze of a new mother with a lie. "She has a sprained wrist. Nothing to worry about," he said. My wrist was not sprained. The C5 and C6 nerves in the brachial plexus region of my neck, associated with the cervical region of the spine, were torn. Self-advocating for answers, my mother discovered that I had Erb's palsy, a paralysis of the brachial plexus, which affects mobility in the affected neck, shoulder, and arm. The doctor's deception had already taken precious time from rehabilitating what movement I had left. Immediately, she practiced gently opening my hand and uncoiling my wrist on her own. As I grew up, societal norms encouraged, even rewarded, the hiding of my disability. By the grace of my mother, I eventually gained enough mobility to pass in specific settings, sedentary settings in which long sleeves could be worn. I thrived in classrooms and eventually got an undergraduate degree in sociology before pursuing a master's. I never applied my experience as someone with a disability to my research prospects. In fact, I dissociated from my disabled experience unless I was forced through random occurrences to confront it. I never inquired about my arm, about implications for neuro. The summer before deciding to apply to graduate school, I stumbled upon an interdisciplinary model that combined hard and soft science when reading George Herbert Mead. As I began reading about the central nervous system, my entire worldview shifted. I realized that the physician who delivered me did not just take away my ability to do cartwheels. He interfered with my brain's development and potentially altered the way it receives input and produces output. Mead discussed the principle of parallelism that stated what takes place in consciousness runs parallel with what takes place in the central nervous system. He discussed that the CNS is a hub for sending signals from the nerves in various spinal regions to the brain. The brain uses these stimuli to create reflexes. When humans interact with each other, they undergo a conversation of gestures, wherein stimuli create instinctive reflexes that are reflective of the attitude of each person. And as the observer of someone given a reflex, we have automatic interpretations of what certain reflexive body movements mean. If my reflexes as a physically disabled person are different than normal reflexes, are individuals misinterpreting my intentions? I always felt my disability caused social rejection, but perhaps there's a science to being misunderstood. More than anything, being given scientific tools opened up my inquisitive mind to ask bigger questions about the implications of Erb's palsy within and outside of the body. I learned more specifically that my birth injury, Erb's palsy, affects the peripheral nerves of the brachial plexus. At the point of injury, nerves are stretched or torn in this region, and on a microbiological level, chaos is fomented. But in a collaborative effort, microbes work to tackle the systemic ruin. Nerve cells have thread-like parts, axons, that are conduits of electrical signals, impulses. They carry signals from the nervous system to other areas of the body. Schwann cells are non-neuronal cells in the nervous system that support neurons. They specialize in forming a protective layer around the axons in a process called myelination. When a nerve injury occurs and one or several nerves are stretched or torn, debris from the Schwann cell's protective barrier seemingly trashes the surrounding area, causing the body to react with inflammation and increased pain responses. Clearing the myelin debris is crucial for the nerve cell and surrounding cell's health, and for providing the greatest opportunity for regaining partial or total function through regeneration. MER is a tyrosine kinase receptor, also known as MERTK. Proteins Gas6 and protein S bind to MERTK, activating it and signaling clearance of the debris to begin. In the clearing process, microbes digest the debris, breaking it down to its most basic components, reducing inflammation and releasing it back into the cell where it can be utilized for resources that aid in regeneration, giving new life to all of the seemingly disposable parts. The protein acts as a disability advocate, rejecting the idea that disabled Schwann cells are disposable, undesirable, or inferior. Rather, MERTK encourages systemic regeneration through adaptation and innovation of these atypical energy sources, finding niches for every molecule. Doing so, just like taking the time to incorporate people with disabilities into the societal framework, encourages systemic growth.